Clodson, I have been contemplating the fundamental nature of mechanical calculation, and I believe I have deduced the entire future of computing. You see, these machines currently operate on what I call deterministic principles, pure logic, if you will.
Deterministic, Holmes? I'm afraid I don't quite follow.
Elementary, my dear Clodson. Think of it as the difference between Mrs. Hudson's tea routine and, well, your attempts at organizing our case files. One follows precise, predictable rules. 2 sugars, milk first, precisely at 4 o'clock. The other is complete chaos.
I see. So these calculating machines follow rules like Mrs. Hudson's tea service.
Precisely. Everything reduced to the simplest possible signals, like that binary system of communication I theorized about. Remember my paper on medieval castle signaling? A single torch flame either burns or it doesn't. One signal for invasion readiness, another for all clear. Pure binary logic.
Ah yes, your castle theory. But Holmes, didn't you get rather confused last month when trying to interpret the smoke signals from your pipe experiments? You kept insisting 2 puffs meant bring tea, when you'd never actually established any such code.
That was entirely different. I was developing a more sophisticated system. But mark my words, Clodson, the future lies not in this rigid, deterministic approach, but in something far more revolutionary. I predict that future calculating machines will operate on probabilistic principles.
Probabilistic? That sounds rather like guessing?
Not guessing, Clodson. Educated prediction based on mathematical probability. Imagine a machine that could learn from vast amounts of data, developing behaviors without being explicitly programmed for every conceivable scenario.
But surely, Holmes, we want machines to be reliable? When I use the cash machine at the bank, I rather expect it to give me the exact amount I've requested, not an educated guess.
Of course. For mundane tasks like arithmetic, deterministic behavior is essential. Your calculator must always produce the same result for 2 plus 2. But consider more complex challenges, like understanding human language in all its nuance and complexity.
Human language? You mean like when you dramatically declare the game is afoot? And I have to guess whether you've actually discovered something important, or you're just being theatrical?
Clodson, you wound me. But yes, precisely that kind of interpretive challenge. You see, human communication cannot be reduced to simple rules. How could you possibly program a machine to handle every potential conversation, every possible question?
Well, how do you handle conversations, Holmes? You seem to manage well enough.
Through years of experience, pattern recognition, and intuitive leaps. And that is exactly what these future probabilistic machines will do. They will be trained on enormous amounts of text, learning to predict the most likely next word in any given sequence.
So if I said, last but not the, you believe a machine could complete that phrase?
Certainly, last but not the least. The machine would analyze thousands of similar patterns and select the most probable completion. It's really quite brilliant when you think about it.
Rather like when you finish my sentences during our conversations. Are you saying you're operating like one of these future machines?
Well, that is to say, my deductive processes are far more sophisticated than mere probability. I use logic, observation, and brilliant reasoning.
Of course, Holmes. But when you interrupted me yesterday to say, Clodson, you're going to suggest we visit the British Museum, and I was actually going to suggest lunch at Simpson's, was that logic or probability?
A minor miscalculation. The point is, these artificial minds will represent a complete departure from traditional computing. Instead of following predetermined rules, they will learn patterns from data, mimicking the very processes of human cognition.
Mimicking human cognition? You mean like when you observe my habits and predict my behavior? Though you did confidently predict I would choose the lamb yesterday, and I ordered fish.
Clodson, you are missing the profound implications. These machines will be able to generate language that sounds convincingly human. In fact, I predict someone will develop a test. Let us call it the Turing test, after that brilliant concept I've been developing.
You've been developing it, Holmes?
Well, refining it, certainly. The basic idea being, if a machine can communicate so naturally that you cannot distinguish it from a human, then it has achieved true artificial intelligence.
Fascinating. So this test would involve conversation.
Exactly. A human judge would engage in dialogue with both a machine and another human without knowing which is which. If the judge cannot reliably identify the machine, then the machine has passed the test.
Rather like our dinner party last week, when you spent an entire evening convinced that Mrs. Pemberton was actually her twin sister Margaret.
That was a perfectly reasonable mistake. They are identical twins, but yes, the principle is similar. The ability to fool human perception through natural interaction.
And you believe these future machines will actually achieve this level of sophistication?
Undoubtedly. Consider the implications, Clodson. Instead of rigid, rule-based programming, these artificial minds will operate through what I term neural networks, interconnected systems that process information much like the human brain.
Like the human brain? How exactly would that work?
Well, you see, the brain consists of countless interconnected neurons, each processing and passing along information. These artificial networks would function similarly, with mathematical weights and connections that adjust based on experience.
So each artificial neuron would be like a tiny decision maker.
Precisely, and through training on vast datasets, these networks would develop the ability to recognize patterns, make predictions, and generate responses that appear intelligent and natural.
This all sounds rather complex, Holmes. How would you actually build such a thing?
The technical details are, well, they would require significant advances in both mathematical understanding and mechanical engineering. But the principles I've outlined are sound. The key insight is moving from deterministic to probabilistic processing.
I see. And you're confident this probabilistic approach is superior?
For certain applications, absolutely. Traditional computing excels at precise, predictable tasks. But for handling the ambiguity and complexity of human language and behavior, probabilistic methods are essential.
But Holmes, doesn't this create its own problems? If a machine is essentially guessing, how can we trust its responses?
An excellent question. The beauty of the probabilistic approach is that while individual predictions may be uncertain, the overall system can achieve remarkable accuracy through sophisticated statistical methods.
Rather like your detection methods, then. Individual observations might be wrong, but your overall conclusions are usually sound.
Yes, one might draw that parallel, though I prefer to think of my methods as more rigorous than mere probability.
Of course, Holmes. Though I do recall that case last month where you were absolutely certain the butler was guilty based on what you called overwhelming evidence, and it turned out to be the gardener.
The gardener was clearly in cahoots with the butler. But returning to our discussion of artificial intelligence, the truly revolutionary aspect is that these machines will learn to generate language without being explicitly programmed with grammatical rules or vocabulary definitions.
They'll just absorb language patterns from examples.
Exactly. Feed them enough text, and they'll internalize the statistical relationships between words, phrases, and concepts. They'll learn that certain words typically follow others, that particular phrases convey specific meanings.
Remarkable. So they'd be like children learning to speak.
An apt comparison, though operating at vastly accelerated speeds and scales. Where a child might hear thousands of sentences, these machines could process millions or billions of examples.
And you believe this would result in truly convincing artificial conversation?
I'm certain of it. In fact, I predict that within a century or two, people will be regularly conversing with artificial minds, perhaps without even realizing they're not speaking to fellow humans.
A century or two? That seems rather optimistic, Holmes.
Mark my words, Clodson. The probabilistic revolution will transform not just computing, but our entire understanding of intelligence itself. We may even begin to question whether human cognition operates on similar probabilistic principles.
You mean we might just be very sophisticated guessing machines ourselves?
Now you're beginning to grasp the profound implications. If artificial minds can convincingly simulate human thought through probabilistic methods, what does that suggest about the nature of consciousness and free will?
Rather unsettling when you put it that way, Holmes.
Unsettling, perhaps, but intellectually exhilarating. We stand on the brink of discoveries that will revolutionize our understanding of mind and machine alike.
Well, Holmes, your predictions are certainly ambitious, though I can't help but notice that for someone advocating probabilistic thinking, you seem rather deterministically certain about these future developments.
That is, well observed, Clodson. Perhaps even my predictions operate on probabilistic principles, highly likely, but not absolutely certain.
Indeed, Holmes, rather like your theory about Mrs. Hudson's tea schedule being perfectly predictable, until last Tuesday when she served coffee instead because she'd run out of tea.
Yes, well, even the most deterministic systems can encounter unexpected variables. But the fundamental principles remain sound.
Of course, Holmes, they always do.